Hello everyone, this is our last Inventor lesson. As you heard me right, this is our last Inventor lesson. So today we're going to be going over a few more advanced tools with the IPT files, the part files, and then we'll be learning a new type of file called an assembly. If you look here on our front screen, we have part, drawing, assembly, and presentation. So we've gone over part and drawing, but we're going to go over the assembly now. We're not really going to go over presentation because we don't really use that one very often, but I can show you what it is used for toward the end of the lecture. Now, what we're going to do is we're going to go into the part first. We're going to start with the part, then go to the assemblies. So the features that we're going to show you are shell, sweep, loft, and the rectangular array. Now, what we're going to start off with is just a simple sketch at the base, and we're just going to make a square. Doesn't even really need to be a square, just that works good enough. Finish. Now what we're going to do is we're going to go ahead and make those offset planes like I mentioned previously, but as you can see, I don't have any of my planes actually visible, so I can't make an offset plane. So what we're going to do is we're going to make that bottom plane visible. We can either make the bottom plane visible, or we can just go ahead and select it from the tree. But I like to be able to see them, so we're just going to do this. We're just going to specify a height, so I'm going to make it 2 inches tall. And now we have a new plane. So I'm going to start a new sketch on the plane, and I'm going to draw a circle. Yeah, that looks good. So now that we have those two drawn, we can do something called a loft. Now a loft right here, if you look under create right next to revolve, it takes two shapes and transitions them to one another. As you can see in this little window, you can make some rather complex shapes with loft. I've made actually airplane bodies with loft before. So now what we're going to do is once we click on it, it wants us to add the sections, okay? So we're going to select our sketches. So we select the bottom and the top. You can do it in reverse order, and then we're going to click OK. You see there's a window for rails. That is more for much more advanced lofts. That's actually helping define how the loft moves from feature to feature, from face to face. So now, as you'll see, if you look from the side, it just kind of looks like a cone. But what we've actually done is we've transitioned, not perfectly, but as good as we can ever do, from a circle to a rectangle. That's why we see these lines. Now, if you were to actually look at it, we have a round face that transfers to a straight face. So that is what loft does. Now, the next tool we're going to use is shell. Now, shell is actually under modify instead of create. So this does exactly what it sounds like. The shell creates a, shell of the part. So we're going to click on shell, and then it already selected the body. Now, the other thing we can do is we can change the thickness of the walls. Now, it already had a pre-selected 0.1 thickness, so what we're going to do is just change it to 0.0625, so 1/16 of an inch, and you can see that the walls got thinner and the hollow space inside got bigger. But one of the other things we can do is take a face and remove it. So what we're going to do is we're going to click on the bottom, and now you can see we have this hollow feature. This is really nice. The shell is really nice for creating like air ducts. And then if we don't actually want that, get rid of that. Never actually clicked on the side before. We'll see what happens. It does not like doing everything. So it did not like me clicking on the side. So we're just going to get rid of it. But it will let me click on the top. And then you see just a hole. So we just take out both of them. And we click OK. And now we have this hollow feature. But be wary. While you can go really, really thin, you cannot go infinitely thick. There is a limit to it. See, I had to think about it. So the automatic limit it set was, initially it was 0.1. 0.1. But once I changed it to 0.15, that small change, it really did not like that. So if I change it to 0.15, it doesn't even want to do the shell anymore. So we're just going to stick with the original one we just had, even though we're going to be deleting this entire part here in a second. So that is how we get those. And if you ever want to get rid of these work planes, because I know they can get rather bothersome and they don't look that great, just right click on them and hit visibility. Same thing with the one that we just created. Alright, there's our part. Not too much to do there, but we're going to go back and get rid of both of these. Okay? We're even going to get rid of the other work plane. I don't really need the work plane. And the original sketch. Don't need any of that. But we are going to turn on all of our origin planes. I do want those. So, it's a little odd like that. This is not the axes. But what we're going to do is we're just going to make a path now. We're going to go over sweep. So, in sweep, I'm going to just make a path with a couple arcs. So we never went over the arc tool, but what you do is you pick the end of the arc, and then you pick the middle point, and this is how you make one. Okay, so we're just going to make a couple arcs here. Just a arbitrary path for the sweep to follow. Okay, and that looks good. Now, when doing these, you can also take the tangent constraint and make these tangent to one another so they transition a lot better. It's not sharp. So now we have this profile, but I want maybe a hose or a tube to follow this path. So what I'm going to do is I'm going to go ahead and finish this sketch and make a new one on this surface. Okay? We're just going to draw a circle real quick. And maybe I want to draw a second circle. Maybe I want this to be a tube. Click OK. Alright, so now what I've done is I have my path here, and I have a profile to essentially extrude along the path. That's all the sweep is. Instead of just extruding in a single direction, we can extrude along a path. So now what we're going to do is we're going to hit Finish Sketch, and we're going to hit the Sweep tool, which is right above Loft. So, as you can see, if you hover over one of these tools, it automatically brings up a little preview of what it does. So we're going to hit Sweep. So we have Profiles and Path. Right now I'm just going to select the path first, but as you can see, it selected the whole thing, even though this is 3 different lines. It can tell when the path is connected or not. And now I'm going to select the profile. As you can see, I can either select this profile, the outer profile, or well, I could have selected both of them at the same time. That was the previous. Or I can select all of these. The actual outer one that I'm looking for. So it gives us a little preview here. Now, notice it also has orientation. So, right now, it's following the path. Now we have fixed as well. So, I'll just change it to see what it turns out to be. So, as you can see, it looks a lot different because what happens is in fixed, as you can see in the picture, it keeps this profile straight that we're extruding, and it just kind of keeps going straight and straight and straight all the way through, whereas this one, it actually follows it properly. So most of the time, you're just going to be using this orientation. So now we just hit OK. We're just going to hit yes, and sometimes it'll pop up that little error because it doesn't like it. And then we have this. Okay. Now these 3 tools can sometimes be very intensive and finicky. So if they don't work out the first round, try not to be discouraged. They are, even for me that I've been using this for almost 7 years now, this can be tiresome sometimes to try to get certain parts like this. So the last thing we're going to do, we're actually going to get rid of this entirely now. Again, we're going to make a rectangular array. So the last thing we're going to do is this in the part file, then we're going to move on to the assembly. So rectangular array sounds exactly what it sounds like. So I'm just going to make, doesn't have to be a rectangle, I'm actually going to make a circle. And all we do is we go up to Pattern, hit Rectangular, obviously select whatever we're mirroring, and then we hit Direction. But now you can see I don't really have any other lines drawn here, so we're actually going to hit Cancel, and then select my axes that I want. Oops. Yeah, there we go. So now that I have the axes, I can just select those, but we select the geometry and we select the direction. It's not letting me select them. Alright, I guess I'm forced to draw the lines. This is nice where that construction line tool comes in. So now that I've drawn these lines, I'm going to go ahead and select them and then make them construction lines. Alright, now we can do the rectangular array. Select the part, and then we select direction 1. Doesn't have to be this one. And then we select direction 2. Alright, so now what it's done is this is the number of parts it's making. So we're just going to get rid of this entirely, and we'll just focus on one direction because it's going to apply the same way. So this is the number of them. So maybe I wanted 4 of them. Maybe I wanted 20 of them. It makes all of them, okay? So there's 20 of them there. So we're just going to stick with 3, though, for now. So now, what we're doing here is the spacing in between, okay? So now they have 1 inch in between themselves. If I do ½ inch, they're much closer. If I do 3/4, they're a little farther away. If I do 20 inches, they're ways away. And the same applies to the other direction. So these two directions are independent of each other. We're going to select the other direction now. And now we have both of them. And I can now select like 10, or I can just select like 1. It doesn't like doing 1. It's got to be a minimum of 2. And you can also change this one. So maybe I want a 0.5 on this way, but 1 on the other. So you can play around with this a lot. We're just going to stick with 1 and 1 and make it 3. Next square. You see here that it says flip. Flip just means flip the direction. So you can see the little arrows. So just flip the direction of the arrow and then vice versa. Okay? So we hit OK, and now it makes all of these. Now, if I'm not mistaken, if I change this, it should change the entire. Yes, it did. All right, that is all it is for rectangular. So we're not even going to actually keep this drawing at all for the assembly. So we're just going to get rid of this entirely. Don't even want to save it. No. So now we're going to start an assembly. Just to keep in mind, for the assignment, you only need to draw one of the 4 parts on pages 14-5 and 14-6. All the others are posted to Canvas, so keep that in mind. So this is the assembly window. Looks pretty similar to all the other ones. But now what we're going to do is we're going to go ahead and hit Place. Now Place takes components that we already drew, so other part files, you can see them all listed here, and then it puts them in the assembly. So right now I have bolt, bushing, clamp, and then I'm going to use the week 4 part that I drew. So right now you can either just select one at a time and place it, and as you can see, you can place more than one. So in my case, I'm actually going to need 4 bolts. So we're just going to go ahead and place that, and then you right click and you hit OK. Or you can hit escape. And then place, and then bushing. But now see, you can also place them more than just one at a time. So these ones, I need 2 of each. I need these 2. Boom, now we have them in our file. And then we're finally going to place the actual main part, which is the week 4 IPT. That bad boy. So now what we're going to do is, you notice we can actually move these around in space, but one of the issues when we actually start putting stuff together is that when you're trying to move stuff and put it together and you don't actually move them like this, it helps, but not entirely. We can do something called grounding. So if we right click on this part and we go down and see grounded, if we click it, you'll notice there's, if you look over in the model tree, there's a little like a pin you use on a cork board. So now this part don't move at all, but these parts still do, which is really nice. So we're actually going to go ahead and change the view of this to shaded with edges. Makes it a lot easier to see. So what I'm going to start doing is assembling these parts. So you don't just move them there, because that's just silly. There's got to be a better way for it. So what we're going to do is we're going to use something called constraints. So as you can see up here in the relationships window, there's the constraint button. Joints are a little more advanced than constraints. They both allow for movement, but we're just going to stick to constraints because they're a lot easier to apply. So what we're going to do is we're going to hit constraint, and now we have all these other options. So we have this one, which is the mate constraint. We have the angle constraint, tangent, insert, and symmetry. You don't really use symmetry a lot. The ones that I find you use most will be the insert and the mate. Every now and then I find myself using angle, but not near as often as those two. Few times I've used the tangent constraint, but that one's slightly more usable than symmetry. I've never used symmetry. So what we're going to do is in mate, you literally select a surface, an axis, or a plane. So what I'm going to do here is as you hover over parts, you can see in the cylindrical surface, it doesn't actually select the surface, it selects the axis. So it selects the axis. If you look at a face, it selects the face. You can also select an edge as well, as you can see on all of these. And you can also select a point. Now, something I will caution you. When you're trying to mate and put together two cylindrical surfaces, use the axes. They're a lot more predictable than using the face, the dot. And I'll show you just why. So what we're going to do is we're going to take that and we're going to mate it to this. Now it looks all right. We're going to hit apply and just get out of that window. Problem is though, now it can rotate around that point because those are the only 2 points that are actually mated together and fixed. But if I go ahead and hit constraint and select the axes and the axes over here, hit apply and get out of it. Now it can only slide because the 2 axes are the same. But now you notice that it's not, they're not flush with each other, they can still move. So we're going to go back into constraint again. We're going to stay with the mate constraint, but you see there's 2 options. One is called mate, the other is called flush. So we just mated these 2 axes together. Now I want flush. So flush, you take 2 surfaces you want, and it gives you a little picture of what happens, and you do that. It's not really too complicated. You'll see the mate has 2 faces pointing each other. So if you were to take the perpendicular of each face, the perpendicular arrows point at each other. But for flush, the perpendicular arrows point in the same direction. Okay? So we're going to go ahead and hit apply. Now we're going to do the exact same thing with the other one here. But you'll notice if I stay with flush, it does not let me select the object. And you don't necessarily have to have them done in the same order. So if I do flush, you can see it's flush with that surface now, even though it may not look like it. But if you move it, you can see it's flush. Now we're going to go back into constraint and then mate. Okay, so now we have our 2 bushings in there. And now we have these little clamp tabs. So we're just going to go ahead and use the surface one. We're just going to select surfaces here. Now the nice thing about holes when you mate them together, make it really easy to put everything together. But in this case, I'll show you if we didn't have these holes, how to mate something like this. So these tabs, we're just going to select one of the faces, go on this portion right here, and here these slots. Now you'll notice I selected this face, and the long ways it would go over here. Okay? But that's not necessarily true. I can always select some other face. I can always select that face, and now it flips around. So it mates those 2 faces together. Now we're going to hit apply, and then we can keep going. If you hit OK, it just gets out of this menu entirely. If you hit apply, it lets you keep going. So now we're going to keep going with mate. We're going to select that face, and now we're going to move it around, do some orbit, and select the face behind it. Okay? Now it's aligned in the slot, side to side, front to back, but not up and down. We can still move it up and down. So now we're going to go ahead and constrain the bottom to this face. And that is all done. So that's perfectly constrained where it needs to be. Now there are different ways of doing it. You didn't have to do it in that exact order, but I'll show you why I personally like the holes. They're a lot easier to use. So what we're going to do is we're going to select this hole, go over to our part, and I want it to mate with this hole. So now these two holes have the same axes. So if we move it around, it just spins around. Now we're going to do the same thing with the other hole. Same idea. Hit apply. And now, with the same two constraints, we've had the exact same thing we just had over here without doing the last face-to-face constraint. So those were a lot easier to apply than pivoting around, trying to get those other two, the faces, to see them. So now what we're going to do is we're going to do the exact same thing, is get that bottom face, top face, apply, and we're done with the clamps. But now we have the bolts. Now I'm going to show you two different ways you can do the bolts. One is going to be far easier than the other. Honestly, it's just one extra steps removed, but when you're doing 20 different bolts, it makes a lot of it, a much great difference. So we're going to take this cylindrical face, select it, and again, this is nothing new. We're going to apply, and now it's in there. But now what we're going to do is we're going to select, back to constraint again. We're going to select that face and that face. And now our bolt's in there like we want. It can still spin, but that's not really a big deal. We don't really care about that. Now, instead of doing it that way, we're going to go to the insert constraint. This is the one I like. Now, what you'll notice if you hover over, this arrow now appears. And it selects to only cylindrical surfaces. So what we're going to do is we'll select that downward arrow. And then if we select this, now we have an upward arrow. So if you'll notice on the two options here, we have the opposed or we have the aligned. Right now we're doing oppose. So boom. Once we select them both, we just did the same thing as this one, but in one step. So it's a lot easier. So I'm just going to go ahead and place the other two bolts here. Like I said, so much easier if you're doing a lot of them. And now we have our, partially assembled printer carriage that I designed a few weeks ago. Now, one of the other things we can do is design a new part in an assembly, directly in the assembly. What we're going to do is we're going to hit create right next to place. It's going to bring up a little window, so essentially we're creating a new file. We're going to call this heater block. Okay. We're going to hit, and this is the file location, standard IPT, all that. Click OK. Now it's asking us for a face. We can either make it, out in the open here. I could literally click right there. We'll give it a hot second. And then hit that, and it's the origin is where I clicked. Or, so, too far. Now it won't let me go forward. Oh, there we go. Let it update there. Or we can hit create again. Now you see it's moved to part 6, so I'm actually probably just going to have to make, should call this one heater block 2, since I already created a part. Click OK. Or we can select a face. It really depends on what you're using it for. So now you'll notice that my origin plane is now aligned with that face of the part. But you'll notice I can see through this part, and when I start drawing, the assembly will look almost ghostly. And as I draw, the actual part I'm drawing will look more physical. So what I can do now is I can actually get all these other surfaces and project them. So when you have a part that you really need to match up perfectly and it's rather complicated, making the part in an assembly is often easy. So what we're going to do is we're actually just going to connect these two projections, hit finish, and we're just going to go ahead and just outright extrude this part. Oh, it didn't click. There we go. And we're not making it that tall. Maybe ½ inch. Yeah, ½ inch looks good. And now, I selected the wrong hole over here. But that's not really a problem. I don't really care at this point. Yeah. Now we'll go back and fix it. Okay. There, we just want the little one. Oops. There we go. Okay, that's better. And now we're done. So now we click return, and now we have this done. But you'll notice we can still see that plane. So if you see the little plus, we can just go over to the work plane, right click, and then hit visibility. And get rid of it entirely, and now we have this new part that took us not as much time as when designing it in just a straight up IPT would have been. But you'll notice it has this little red arrow, green arrow, or blue arrow going on. So that makes, I can't remember whether it's adaptive. Yes, that's what it's called. So if this part were to change, say the width got longer, so instead of the distance between this face and this face being 2 inches, say I made it 3, that part would actually change in accordance to that extended width. So instead of the width of this being 2 inches, it would be 3 inches. It would automatically update once you opened up this assembly, which is really nice. You just got to be careful with it. When you do too many of these, it gets a little tricky, especially when you make big changes. So that is pretty much all for this. Now what we're going to do is we're actually going to hop on over to a drawing. So we're going to go ahead and save the this assembly here as last week of Inventor. We're going to hop on over to the drawing. We're going to leave the sheet size as is. We'll change it just as a review. So we'll edit sheet, and we'll go with B this time, 11 by 17. So now we're going to place the drawing, and now, as you see, it's automatically selected the assembly, and you notice that it's an assembly by the .iam. And now we can actually do front, tops, and side views, and the isometric. And we're going to click OK. And now we have our wonderful drawing. But now, drag you over. We have all this wonderful drawing. But maybe I want to know how many of each part I need and what parts I need. So what we're going to do is we're going to go over to Annotate and click Parts List. Okay? So we're going to select the document. So it's going to be this one. We're going to click OK. Yes. Just click yes. So now we're going to option. It's either put down in this corner, up in here. For what I'm going to do is I'm going to put it down here. Okay? So now I have this parts list. And notice the part number is the name of the file. Okay? So you'll notice that last week of Inventor, the title of the assembly is not here, but the parts are. Okay? And what we can do is we can edit this. So if I right click and click Edit Parts List, we have this new window pop up. And if we want to change what's in the table, we click Column Chooser. Now, these are all the available columns that we can make, and these are the ones that we currently have. Okay? So I actually want to get rid of description, and I want material. Okay? We're going to go ahead and click Add. And then maybe I also want file name, we'll say. We'll click Add. Not too many things we actually want here. So I'm actually going to check with the lessons to see what other ones we need real quick. And actually, that's it. Don't even really need file names. We're actually going to get rid of file name. And you can also move them up. You can, can't move it down any farther. It's as down as it can go. But we can move them up. You can move them all around. We're just going to keep it as such. Click OK. And now we have this. And apply. And done. And now we have our new one. But notice it's not aligned to where we want it. So if you hover over some text, we can go ahead and drag this back to be in that corner. But you'll notice all the materials are generic. There's no way all these materials are generic. They have to be something. So what we're going to do is we're actually going to go back. I still have the bushing open. And usually a material for bushing is either a soft metal or a polymer of some sort. So in this case, nylon 66 can be used, if it's the correct kind, to be used as a bearing, as a bushing. So what we're going to do is we're going to go ahead and select that. So this is now nylon 66. This part is going to be 3D printed, so that's going to be made out of, well, you'll notice that we don't have everything in this part, in this materials list, but we're just going to call it ABS. I would actually make it out of PLA with my printer, but ABS is fine enough. Okay, then we have all these different appearances. So I'm actually going to change the appearance to a, where's it at? We're just going to change it to a medium gray. Okay. So now we have that one and that one changed. We're going to go ahead and go to clamp and bolt, and the clamp will just change here. Again, this one's going to be 3D printed as well. That's ABS. Maybe I want this one to actually be, maybe I just want it black. So we have black now. Okay. But we're going to leave this one and actually go into the Inventor assembly. You notice the Inventor assembly has already updated itself. If we click on a part, we can actually go ahead and go and change this. So this part would actually be aluminum. So this is all alphabetical. I'm just going to select a type of aluminum. And then I'm going to select one of these bolts. And then go ahead and select a steel, because this is going to be a steel bolt. So I can just pick really any of the steels. For this application, we're just going to go ahead and click steel carbon. Actually, we're going to select one of them, a different one. We'll do stainless steel. Make it a little shinier. At least it should have. And again, you can have different appearances too with these. Like you have all of these to choose from. But we're just going to go ahead and stick with this. I'm actually going to go back and change the week 4 color to something lighter. I'm just going to leave it as white. Okay. And again, you'll see that it's already updated. So we're going to go to this, and now you'll see that the table is already updated with what the actual material is. So if we just drag this table over, careful, there we go. You got to be able to select the right part. So now you can see we can adjust all the different columns too, which is nice. But now we have the actual materials we're using. Okay? And if you missed it, the way you change the material real quick, you'll see it's already updated in the actual part file. When I change this one to stainless steel, you go to the top here, choose your material, and then you can change the appearance if you want. Typically, you're not really going to change the appearance. This is not the program to be really messing around with appearances and all. It's more for creating the part, not really making it look good. We have there are other softwares that do rendering, which are better at this. So now, let me check my list here. I have one more thing to go over, just one. And then we are done with Inventor. So you can see that none of this is colored, so you didn't really actually see a change here, but that's where you'll see the change. Now we're going to stick with Annotate, and we're going to do Balloon. So now what we're going to do is we're going to select a part and then make a leader for it, and click OK. So what I'm doing now is we're actually going to get rid of all these drawings. We don't actually want these right now. So I'm going to go ahead and delete them. Yes. So I actually just want this one for the assembly, so we're just going to make this bigger. Usually when you show off what parts are which, you want a bigger picture of the overall assembly. But we're going to go up here to Balloon, and we're going to select each and every part. Once we click on the part, you'll notice it drags off to the side, and then we can keep like dragging, but just as soon as you do one click out, just hit right click and hit continue. And you just do all the parts. There we go. So now we have almost all the parts. It seems that I missed one. Because we have 1, 2, 4, and 5. We'll go over to 3. I missed the clamp. There we go. Now we have our little balloons, our leaders, created. So now what we're going to do is we're just going to go ahead and fill in the eye properties after hitting escape. We'll just do assembly. Leave that, and then type in the company as Penn State Iron. And there we go. We are all good to go. So that is it for the lesson. You all have been doing much better with the submissions, and I hope you have a great rest of the semester. Thank you.